I guess I better start off with best laid plans sometimes go awry. When I wrote the abstract for this talk, I was expecting to be able to interpret all of these sites and it was going to be really amazing. But I had a little bit of a back breakdown, and so I fully have to admit that I'm going to be sitting down for this talk, and the Percocet level is interesting. So, just as sort of a bit of background, in 1985, I was a struggling freshman at the U of A, and I was in the Management Information Sciences program. And I had an interesting first year, and I did extremely well in all of the classes except for my major, in which I failed COBOL programming, which, as most students would take it, as a pretty serious academic crisis. And I didn't really know what the heck I wanted to do. I had taken Archaeology 101 from John Olson and absolutely loved that class. And I was kind of in a depression, and my mom said, well, you like the archaeology class, why don't you go on an excavation? So I did, and I got hooked. Everything about the excavation process, the use of the Cartesian grid system, the note-taking, the record-keeping, it just struck something in my mind that I really enjoyed. At the same time, I had always been a hobbyist in 3D computer programming, which for 1985 basically meant drawing 15 or 16 lines in space and pretending it's an airplane or something like that. But I went to Dr. Olson and said, I think I'd like to change my major. I think I'd like to, I have this dream about somehow combining what I've been doing with computing with archaeology. And I really never looked back since. And so I'm going to talk a little bit about the ways these technologies developed over the past 25 years. And then we'll get to some rather more interesting stuff. My first real go at when I really decided, okay, this is what I'm going to be doing with my life, was working with the Homology Research Program up in Winslow. And it was at this site, Homology 4, which had such a dramatic three-dimensional component to it compared to the rest of the sites at Homology, which were relatively flat, that I thought, well, this is a perfect place, a perfect test case to start playing with 3D and archaeology. And one of our fellow crew chiefs mentioned, hey, there's this program called AutoCAD, and AutoCAD will let you draft in 3 dimensions. And okay, I'm hooked. And the U of A had a software library where you could go and check out a program for a couple of weeks and try it out. And we tried it out at the State Museum, and I was so excited. I started with incorporating traditional survey methods, traditional survey techniques, and this was my first CAD map of the site of the Homology 4. And Chuck Adams, Paul Fish, and William Robinson saw the potential and invested in me, if you will, and went ahead and purchased a copy of AutoCAD for the Arizona State Museum. And from that, everything that I'm about to show you springs forward. This was the first go at trying to bring the data into 3 dimensions. And here you can sort of see the rough outline of how a 2-dimensional plan has been pulled up into a 3-dimensional wireframe. Adding topographic lines, creating a digital elevation model to put the site down upon, and a shaded rendering to show what we thought the site might have looked like. Maybe 25 rooms across the top of the butte, and another 175 rooms cascading down the sides. Then 2 years later, the company behind AutoCAD released a program called 3D Studio, which lets you do things like texture mapping and texture modeling. And in this case, you could drape photographs over your wireframes to get a more believable looking image. And the first texture map was just a simple photograph of some existing masonry up at Hopi. And then they invented bump mapping, which allowed you to use essentially a black and white grayscale map to determine how far things get bumped out, which sort of, as you can tell from the difference of these 2 walls, sort of improved the quality of the rendering. And so a year later, a new model of Model V4 shows up, and it's much more realistic than it had been done before. So the basic data process is the same for archaeology. You collect your data, you assemble it into a 3D model, and then you can push render. And the computer thinks about it, it calculates out all of the light angles, where the sun should be, how the light bounces off rock surfaces, and it spits out an image. In this previous image, let's see if I can go backwards, this took about 8 hours from the time, say, go, to the time it came back with a finished image. But you can just keep repeating this step moving your camera one frame at a time and start making animations. And I don't know if PowerPoint and animations just aren't very friendly these days. Oh, here we go. So this was my first animation. 8 seconds, 30 frames per second. It was 240 images stitched together. It took about an entire week of computer time to make this animation. And of course, it was August, so I was literally praying that the lightning wouldn't turn off the computer. About 12 years later, we began to see an explosion in a new type of data technology with Lidar scanning. And Lidar is using the time of flight of laser beams bouncing off and back and forth between a camera to collect XYZ data points. And here we see a setup. A Model V4 became my test child. Every new 3D technology that comes out, I take it back to a Model V4 to see how it performs. And so this was the first scan of a Model V4. Here we're setting up to scan some rock art. And here's just sort of a graphic that shows the scanning process as it's actually happening. The laser beam is a green dot, and if the sun is just starting to set, you can actually see the green dot scanning, traversing back and forth across the landscape. So that resulted in a scan world of about 14 million XYZ points. Compared to the 2 days of surveying that we had done originally, where we collected 216 points, this was quite an improvement in data density. Here you can sort of see just how dense this particular data is. And from there, it was a careful process of using all of this data to sculpt out a three-dimensional object to represent the site. And that became kind of a tricky issue because you're used to dealing with a paucity of data, and when you're overloaded like this, it takes an incredibly robust computer to be able to pull all this sort of stuff together. But this was the resulting animation. If I can get this one to work. Nope. Come back. This kind of shows how much the technology had changed in 10 years. Obviously, the model is much more lifelike, much more believable. We're able to get vegetation in, and we've been able to model a much larger portion of the site. I'll let this take a spin around. And then since this point, I've been working kind of all over the place, working with various models, trying to model as many different places throughout the Southwest as I've been able to get access to. And it's been really quite a lot of fun. We're going to climb up to the top here, and we're going to see a vessel that does not in any way belong. But I thought it was just a nice touch. So the pieces of the puzzle exhibit will be opening at the Arizona State Museum. These are some of the 3D models from the Phoenix Basin. This is one of my favorites of Pueblo Grande. You can see the big house, the great house that would have been associated with Pueblo Grande today. Obviously, all we can really see is the main platform mound. What this model does not show is the extensive agriculture or the extensive canals or any of that sort of stuff. More projects for future work. So then we were trying to decide what to really do next, and we were fortunate enough to get a National Science Foundation grant to interpret for the public Paul Reed's research on Chacoan migrations in the 10th and 11th centuries. And this made us kind of stop and think, okay, how are we really going to do this? Are we just going to show animations of Chacoan buildings and talk about how people migrated? What sort of ways could we share this stuff with the public? And it was at the opening of the Pieces of the Puzzle exhibit in Phoenix, where this 8-year-old kid looked at one of my models of the Phoenix Basin and said, my Xbox is much better. Yeah, you're right, it is. And we sort of came to the conclusion that it really was a logical next step to try and incorporate a game engine to start sharing archaeological interpretation. And we played around with a bunch of different ideas with this, and eventually settled on a package called Unity 3D, which was, for our needs, a pretty good choice. It offered a very robust way to work with objects as programming objects, as well as just simply programming exhibits. And so our goal became to create a touchscreen exhibit that would match what was going on in gaming at the time, which was World of Warcraft. And I don't know if any of you are familiar with World of Warcraft. Some people used to call it World of Warcrack. Millions of people log on every night to play their fantasy role-playing game. So we had the idea of, well, let's make a massive open museum that people can log into, walk around as their own avatar, explore spaces on their own, and create just a new type of museum that could be served over the web that would be truly virtual. And so we started working on some basic concepts. And here was the first sort of trial of a virtual museum concept. And the point of this room was to get the user acquainted with the user interface. And we were using a user interface that was based on a first-person perspective. For the gamers, it's a first-person shooter. We wanted to change that to a first-person shooter. So we took away the guns, but put in the information. And we tried it out. Here's a portal leading into Salmon Pueblo. And I tried this out with various co-workers at Archaeology Southwest. And again, here's just some of the most beautiful work Unity can do for us. And it really is a very nice rendering image. This, of course, being Earl Morris's reconstructed Great Cuba at Aztec. But what really wound up happening was all of the people who tried out this virtual museum wound up lost in these virtual cornfields. And they, who am I? Why am I here? Why am I lost in a cornfield? Where's the archaeology? And so it was clear, we needed help. So just through Twitter, I ran into a programmer named David Coons, who took one look at this and just said, "This will never fly. You won't pass the grandmother principle. If your grandmother can't work with it, if it doesn't work for interpreting for your grandmother, you're wasting your time." And ego deflated, I had to agree. But working with David, we came up with this alternative concept for a node-based interpretive system. So by node-based, I mean that you would have spaces, and you could move from space to space, and each space could have interpretive content attached to it. Each space had a 3D model that defined either a landscape, a village, a room, or an artifact. And you could move from space to space. So here we're looking at a reconstruction of Aztec, looking from the north, looking south. And all of those blue lines that you see, all of those faint blue lines that you see there were interpretive nodes where people could navigate through the scenes. And here's some of the background detail, just for each interpretive node, we set it up so that you could attach an audio file, text files, maps, photographs. I'm a little out of sequence here. Here's an example of an interpretive mode where we've got a button for maps, a button for further information, a button for alternative opinions. We could call up and have Steve Lexon's approach to Chaco and Kiva as being something rather different than most archaeologists want to describe. And the ability to share multiple viewpoints, I think, is one of the neatest things about this type of exhibit approach. But to build the model of Chaco Canyon, we start to get into something called photogrammetry. And how many here are familiar with the term photogrammetry? Oh, it's great. You know, it's the technique that was used to make all of our topo maps in the 40s and 50s and 60s. And desktop photogrammetry has just exploded. And so this all leads together to the point where we finally put this exhibit together with Chaco's legacy. Here's the opening screen. The exhibit will allow people to watch the content as an 8-minute movie that just simply goes through 8 specially designed interpretive nodes so that the information flows like a movie, and there doesn't have to be any other user content or user interaction, or people can go in and explore on their own. And we were pretty excited about this. We released it to the public 3 or 4 years ago up at Aztec Ruins National Monument and at Solomon Ruins State Park. And so getting back to the photogrammetry has now exploded. There's this program called Agasoft Photoscan, which allows you to just take hundreds of pictures. As long as the pictures overlap, you can feed them into the Photoscan engine, and the Photoscan engine will spit out a 3D model. So all of the blue boxes that you see here are photographs of the sunset footprints exposure, and that gets processed into a point cloud, much like with laser scanning. Laser scanning first create those point clouds, then generated into a 3D model, and then the texture is added to the model to make the model look realistic. And photogrammetry is everywhere now. At the last SAAs I attended, I saw at least 50 posters with people using photogrammetry to three-dimensionally document and record their sites as they were being excavated. And I'm going to get on a soapbox for just a second here. You're hearing a lot these days about digital preservation, and what that usually means is big companies are going out to threatened World Heritage sites in the Middle East and other places and conducting large-scale either digital scanning or photogrammetry of these places. The problem is that these models are not being released as open data or open source, and if someone wants to actually use those scans, they wind up having to pay a company a huge fee to repay the company for the effort that they put into modeling the site. And it's my position on this that if your scanning data is not open, when you've scanned a cultural resource, if your data is not open to the public, if it can't be downloaded by other people for other scholars to use, it's not preservation, it's piracy. There are obvious, there's obvious exceptions to this rule. I could see many native tribes wanting to record something special of their in their tribal inventories and not want to share that with the general public. And that's their own business, and I'm not talking about that as cultural piracy. And in fact, that's a practice I would love to help teach people how to work with. But we have to do this open data and open source so that we can share these models with all scholars, because it's basic scientific data and it needs to be shared. So last year took the drone out and went back to homology. And so here is the resulting 3D model of homology 4. As you can tell, it's considerably more detailed than anything we've been able to accomplish before. And here are the numbers. They speak for themselves. The laser scanning shot 14 million points in 4 hours, and it took about a week of processing time. The drone collected 254 million XYZ points, all accurate to within 2 centimeters. It recorded this in 15 minutes. It took about 2 days of completely unsupervised computing time for Photoscan to take all of the photos that you saw down below that other image, to take all of those photos and convert it into the 3D model that we were just looking at. And then along came Google Cardboard, and Google Cardboard was amazing. Put it over your head, you're there, you're in space. And at this point, I'd like to turn things over to Drew Castilla here. Drew took over for us when David no longer could work on the CVR project, but Drew transformed our initial interpretive system into something really, truly special. So,
thanks a lot.
No problem.
Hello, everyone. Like Doug said, I'm Drew. I've been working on the CVR for a couple of years now. And when I came onto the project, it was during Chaco's legacy, the example that he showed earlier with all the different conflicting ideas and different perspectives on the Chaco area. I have been steadily adding features ever since then. It seems like every time we find a new application for this project, there's always some new feature that needs to be added. For example, when we're working on Chaco's legacy, we needed to provide accessibility to the hearing impaired, so added subtitles. So we needed to find a way to deploy Chaco's legacy not just to museum goers, but also to users on the World Wide Web, so that you could actually access and explore the ancient spaces of Chaco from your personal computer at home, and not just by visiting the location itself. So the journey of the CVR has actually been it was designed originally for this kiosk type experience, but has evolved into VR. And that journey is actually a tremendously long one. One that involves lots of different design decisions. And as Doug will attest, I will come to his office and sometimes talk over these features and how they'll be implemented in great detail. I'd like to, in a minute or two, once I get this projector spun up, show you a little bit about the guts inside of what we do when developing in Unity for the Chaco project. I heard some of you talking just before the presentation started about the latest phenomenon, the Pokemon Go application that everyone seems to be playing, right? It's part of this new craze in various forms of reality, virtual reality, augmented reality, mixed reality, all these buzzwords floating around about what this means. By and large, they involve using devices, like this gentleman's phone that's welded to his head, to experience not just one image, but two images that are delivered asynchronously to each eye. Do you remember, some of you have maybe been to the theater where you've had to wear 3D glasses, or remember the really old ones with the red and the blue filters? These 3D glasses separate the image that you're looking at into two different parts, one of which is slightly offset from the other, creating the illusion of 3 dimensions. So the craze that's going on right now is this sort of fusion of a digital image, a computer rendered image, and a 3-dimensional one that's delivered asynchronously to your eyes. And that's what we've been working towards as part of this CVR, this chronological virtual reality platform that we've been developing at Archaeology Southwest. Our goal is to help create as immersive an experience for users who are interested in visiting the past. And whereas in many of these renders you can get a great sense of what the substance of these dwellings is, to walk among them is a wonderful experience too.
So I think that's about it. I'd be happy to answer any questions, but that's about where we're at right now. Yeah.
What machine are you using to do all this processing? PC or Mac?
Pardon?
A PC or a Mac?
It's all PC.
Okay.
Drew uses a Mac for the coding.
Yep.
But the virtual reality engine is going through a PC. But you can also use phones and tablets and Linux and really whatever you like.
Got another one over here.
Yeah.
Your point clouds are amazing, especially with the photogrammetry. That blows me away how fast you can do that. How does the user experience vary on the device? For example, is that an Oculus Rift or is it something else?
That's definitely something else. The Oculus Rift is designed for a single point sitting position. And it's the Oculus Rift doing some testing with museum visitors. I started calling it the Oculus Barf because it continually was triggering motion sickness. And I know that they've improved it somewhat where it has a sensor now that can track your head a little bit better, which reduces the level of motion sickness, but it's not room scale where you're able to walk around.
Well, that's pretty amazing considering probably $50 to $100 million of R&D.
Easily.
Seriously, yeah.
Easily.
Yeah, it's a really tumultuous field right now. There are a variety of different companies creating their own VR solutions. Sony has one, Microsoft has an augmented reality headset. Google, as you see, is working on stuff that supports this sort of thing. Valve created the headset that we're using here. So there are all these very large companies doing research in it, and it's one of the reasons why it's still such a frontier, is that everyone has their own standard, and that makes it quite a challenge to develop for, too.
I should mention, the reason we got a hold of this device was because last February there was a conference in Hollywood on virtual reality, and I was doing all of this work on Google Cardboard, and I thought, well, heck, this will be a great place. I could bring my work and trade ideas with people, and no one else had any content. People really didn't realize that virtual reality has been happening for 20 years in cave environments, and people were really surprised to see an archaeologist passing around the Google devices. But half of the classes in this conference were on avoiding sickness. And the first, the inaugural talk, Gabe Newell, the founder of a company called Valve, which creates a lot of game software and creates ways for gamers to buy software very easily, essentially told the entire audience, and I'm giving each and every one of you one of these. And 2 weeks, I didn't tell my coworkers, I didn't believe it, it was just too good to be true. And 2 weeks later, this box is on my doorstep, and here's this amazing device. And I think it was a pretty smart move on Valve's part, because it's inspired a lot of folks to create some pretty innovative solutions.
Yeah, and we kind of feel like paying it forward in some way, right? I mean, it's been maybe a dream that we might get the platform that we're creating in the hands of others at some point or another, in some form or another. So part of our work has been trying to make it easy to use for designers too.
So again, open source, open data. We're writing a user's manual. I've got 3 or 4 people lined up who are going to try to take this on and see how they like using it. And we really hope that this becomes a tool that students will be able to create their own projects on. And one of the interesting things about Unity is they've set it up in such a way that students can download all of this stuff, put all of this stuff together, put their project out there, and they don't have to pay a penny. It's open, and that's for us is incredibly exciting, because I think the more people that use this, the more new ideas we're going to see for how to share ideas about the past, and the better we're going to be able to share these types of stories. Yeah.
How about ground penetrating technology and the devices they'll meld in together like they're doing in Egypt. They're actually penetrating through satellite the ground, and they could find certain archaeological things that they never knew was there. So you think maybe someday that also could be incorporated somehow?
I think these types of technologies could be easily incorporated into those types of remote sensing approaches. And I don't know if you've ever tried to read a ground penetrating radar scan, but when I look at it, I just see gobs of gook. And maybe if it was spread out into a three-dimensional display, that type of data could be more easily understood and more easily measured. So good question, and yeah, I definitely think it's going to be possible. All right, everybody. Well, thanks for coming out.